Assalamu alaikum everyone. Hope you all are fine. My name is Wasif Ali Haider and my group member's name is Anis Ashraf. Guys, today we are here to brief you on the topic Internet Protocol version 6, that is IPv6. So, first of all, let us start with the definition of IP and let us discuss why do we need one. The Internet Protocol, basically IP is the communication protocol in the Internet Protocol suite for relying datagrams across network boundaries. Its routing function enables internet working and essentially establishes the internet. IP has the task of delivering packets from source host to the destination host depending upon the IP addresses in the packet headers. For this purpose, IP defines packet structures that encapsulates the data to be delivered. It also defines addressing methods that are used to label the datagram with the source and destination information. Historically, IP was the connectionless datagram service in the original transmission control program introduced by Vint Cerf and Bob Kahn in 1974, which was complemented by a connection-oriented service that became basis for the transmission control protocol, which is also known as TCP. The Internet Protocol suite is therefore often referred as TCP/IP, about which we also heard in this course. So, coming back to our topic, which is IPv6, why do we need IPv6? Why do we need a modified version of Internet protocols? To understand this, we have to look in the background of IPv4, that is Internet Protocol version 4. So this version of Internet protocols was introduced in 1984. It was described in 1984. At that time, the lack of IP addresses was not even discussed because the stipulated amount of around 4 billion was not even considered enough, but it was considered inexhaustible at that time. The IPv4 specification was first published as the IETF RFC 791 standard in 1981. At that time, the Internet was called ARPANET. It had several hundred hosts and was under control of the US Department of Defense. Things have changed since then, but most of the Internet still uses Internet Protocol version 4, that is IPv4. By 1992, the scalability and limited IPv4 address space became an issue. Changes in the routing architecture and the allocation of address space called CIDR, which were standardized in 1993, have significantly slowed down the consumption of the addresses. However, the warning was noted in an early 1994. The IETF began work on creating a new version of the protocol, later called IPv6. The base specification was published in 1998 and the final version of IPv6 was introduced in 2006. Today, the rapid development of the Internet has reached a point where most of the IPv4 addresses are already distributed. The situation changed by the mid 90s when CIDR technology was introduced, which allowed blocks of addresses to be allocated according to real needs. At, at the same time, regional Internet registers were formed responsible for distribution of addresses and numbers of autonomous networks in accordance with the rules developed by the regional Internet community. The first were RIPE-NCC and APNIC and then ARIN, LACNIC and AFRINC. After the Internet Protocol version after the IPv4 address space ends, the sixth and the fourth generation protocols will be used in parallel, with a gradual increase in the proportion of IPv6 traffic compared to IPv4. The situation will be possible due to the presence of large number of absolute devices that do not support IPv6 and require special conversion to work with the devices that support IPv6. Now let us discuss the limitations of IPv4. The first one is the lack of address space. As I discussed earlier, at that time this issue was not even discussed because at that time the mammoth amount 4 billion was not even considered enough. It was considered inexhaustible at that time. The second issue is weak protocol extensibility. The insufficient size of the IPv4 header, which does not accommodate the required number of additional parameters. The third issue is the problem of security of communications. No means are provided to limit access to information based on the network in this version of Internet protocols. IPv4 has never been designed for security. It was basically designed for isolated military network, and then later on it was adopted for for research network and public education. Lack of quality of service support. Placement of information about bandwidth delays required for smooth operation of some network applications are not supported by this version of protocols. The last one is geographical limitations. Since the internet was created in the US, this country is also involved in the distribution of IP address. US holds almost 50% of the current IPv4 addresses. So basically it is impossible to stop the IPv4 depletion, and transition to IPv6 is inevitable. Moreover, growing demand for addresses leads to appearance of a black market. After the distribution of almost all free addresses, the only way to get address will be on the black market, and prices will rise significantly. If the survival of our business depend on getting IPv4 addresses, you will be ready to pay them even if you must bypass the rules. Fortunately, carrier grade network address translation, also known as large scale NAT, also developed the deal with IPv4 exhaustion problem and to prevent the appearance of the IPv black market. So the next of the presentation will be explained by Anis Ashraf. Thank you everyone. Allah Hafiz.
Bismillahirrahmanirrahim. My name is Anisur Rahman. Today I am going to present IPv6. IPv6. Why? What is IPv6 and why is it important? IPv6 is the latest version of the Internet Protocol, which identifies devices across the Internet so they can be located. Every device that uses the Internet is identified through its own IP addresses. In order for Internet communication to work in that respect, it is just like the street addresses and zip codes you need to know in order to mail a letter. The previous version IPv4 uses a 32-bit addressing scheme to support 4.3 billion devices, which was thought to be enough. However, the growth of the internet, personal computers, smartphones, and now Internet of Things devices proves that the world needed more addresses. Fortunately, the Internet Engineering Task Force IETF recognized this 20 years ago. In 1998, it created IPv6, which instead uses 128-bit and addresses to support the IPv4 addresses. Method of 4 set of 1 to 3 digit number. IPv6 uses 8 group of 4 hexadecimal digit separated by colons. Next is what are the benefit of IPv6. In its work, the IETF included enhancement to IPv6 compared with IPv4. The IPv6 protocol can handle packets more efficiently, improve performance, and increase security. It enables Internet service providers to reduce the size of their routing tables by making them more hierarchical. Differences between IPv6 and IPv4. Differences between IPv4 and IPv4 and IPv6. The key difference between IPv4 and IPv6: IPv4 is 32-bit IP address, whereas IPv6 is a 128-bit IP address. IPv4 is a numeric addressing method, whereas IPv6 is an alphanumeric addressing method. IPv4 binary bits are separated by a dot, whereas IPv6 binary bits are separated by a colon. IPv4 offers 12 header fields, whereas IPv6 offers 8 header fields. IPv4 supports broadcast, whereas IPv6 does not support broadcast. IPv4 has a checksum field, while IPv6 does not have checksum field. IPv4 supports VLSM and IPv6 does not support VLSM. IPv4 uses ARP address resolution protocol to map to MAC address, whereas IPv6 uses NDP neighbor discovery protocol to map to MAC address. IPv6 and IPv4 delay in second. The increase in the FTP file transfer protocol in traffic increases the number of packets, thereby increasing the delay of the network. Delay in IPv4 network is 0.19 millisecond compared to that of IPv6 network, which is 1.6 millisecond respectively. This is to say that when FTP data volume increases, the number of packets in IPv4 increases, thereby causing delay in the IPv4 network. Therefore, the delay in the IPv6 network is less than IPv4 regarding the lesser number of packets in the network. IPv IPv was IPv6 response delay in second. The analysis gives a clear picture of the response time of both IPv4 and IPv6 as it is measured from the time client applicant send a request, the server to the time it receives a response. Packet analysis, the graph when the FTP traffic sent is between 15 bytes to 10 KB with an inter request time of 500 seconds. The response time is low for the both protocol. As data traffic increases, the report time for IPv4 network increase also. The effect of the response time in both IPv4 and IPv6 network is small. IPv6 header format, difference between IPv6 header format and IPv4. IPv6 header is much simpler than IPv4 header. The size of IPv6 header is much bigger than that of IPv4 header. Because of IPv6 header size, IPv4's addresses are 32-bit binary numbers, and IPv6 addresses are 1 to 8-bit binary number. In IPv4 header, the source and destination IPv4 addresses are 32-bit binary number. In IPv6 header, source and destination IPv6 addresses are 128-bit binary number. In IPv4 header includes space for IPv4 options. In IPv6 header we have a similar feature known as extension header. IPv4 datagram headers are IPv6 headers are normally 20 byte in length, but we can include IPv4 option values also along with an IPv4 header. And IPv6 header we do not have options but have extensions headers. The fields in the IPv4 header such as IHL internet header length identification flags are not present in IPv6 header. Time to live TTL, a field in IPv4 header typically used for preventing routing loops, is renamed to its exact meaning hop limit. Features of IPv6: hierarchical addressing and routing infrastructure, stateful and stateless configuration, support for quality of service, and ideal protocol for neighboring node and interaction. Conclusion: IPv6 is a great and important update to an outdated internet protocol, but it is not a perfect solution and it does not fix every challenge with the IoT.